everybody. What a crowd. You guys must think it's sunshiny, huh? It was so beautiful yesterday, wasn't it? How come it didn't extend? Don't you forget now, it's going to get better because we need to push the clocks forward, right? That means it will get better. That's an Indian saying, I think. Anyway, I'm so glad that everybody showed up today, and I'm here to sincerely welcome you to the Duwamish tribe. They do exist. I want you to know they're here. But I have to tell you, I just came back from the United Indians of All Tribes. 44 years ago, they took over Fort Lawton. And they got Fort Lawton. They got part of it. And as I went over to share a little bit of history, and I said, I forgot to tell them that even though we gave up 54,000 acres for Seattle, we do, and we bought back 2/3 of an acre. And we are so happy because now I've just declared this is our reservation. Yeah. So we might be monitoring all these Indians or white people or anybody who comes on our res. Be careful, be careful. I'm not joking, this is serious. I mean, if you give up 54,000 acres, don't you think they should give us a little reservation here somewhere? Don't you think? I'm glad you're on our side, but I'm sorry I brought that up, but I just come back from speaking over at the United Indians, and they're celebrating taking over Fort Lawton a long time ago. And I was there, too, in 1970, and we drove on, we seen all those MPs chasing the girls and beating up on them, the old ladies, young ladies, children, and everything else. It was awful, it's disgusting. But guess what? Got a United Indians of All Tribes, and they still exist. Anyway, heading on, I want you to get out to your program. I seen this sign about 15,000 years ago. Just remember who was here. Was there somebody here? In the top. Oh, okay. Listen, have a good time, and I'll be observing too. And I hope you all signed in and left your $20. Oh, I'm just teasing. No, I'm just teasing because it's a free event, isn't it? Okay, great. Have a good time, and I'll be talking to you later. All right.
So I think this button will do it. I don't usually use a microphone, if you can't tell that, and how loud I'm talking. I'm paranoid about two things today. One is my ability to use a microphone, as you're seeing right now.
But I don't think, can people hear me all the way in the back? Can you hear that?
Don't work for 2 hours of screaming. You can't scream in 2 hours. Be a big boy.
If I turn the mic down, how about, let's do that.
Now you regulate the sound?
Do I have regulated sound? Does that sound better?
Yeah. Okay.
First paranoia down. Second paranoia, I am a geologist. So this is my name, Devin O'Reilly. I know a lot about rocks and water and space and the distant past. My knowledge on anthropology and recent history in no way matches many of the people in this room. So, please bear with me if I bib something. Hopefully, I will not. Sound good? I'm going to have a lot of points where you can ask me questions. I'm going to be covering a lot of stuff pretty quickly, so I would not be surprised if those questions exist. Good? Good. So, thank you very much, of course, to the Duwamish, Longhouse and Cultural Center for having me. Seattle Parks. I'm a Seattle volunteer naturalist, which is a delightful, fun opportunity to teach environmental science to Seattle's youth and visiting youth. For Culture also sponsored this program, and I especially want to thank these Highline High School volunteers in the back who were doing a senior project today, cleaning up at Terminal 107 directly across the street. I am born and raised in South Seattle. I went to get educated up in Bellingham at Western Washington University. I worked for a while for Skagit County in their Water Resources Division. I worked for a while as a field geologist, as a hydrogeologist for a private company. And now I'm lucky enough to spend my time doing the Seattle Volunteer Naturalist, volunteering and working at Highline High School, and working with Seattle Public Utilities on a Creeks Advisory Board. But what's that really mean? It means I think I'm going to take you to lots of pretty places, but probably I'm just going to take you to a quarry, right? I think I know the cool, beautiful spots to go, but I'm probably going to end up sampling at a dump, right? Or sampling next to a dump, because those are the places that people need to take environmental samples. Sometimes the dump is right next to Mount Rainier, which is pretty nice. Okay. So, I want to know what you know. Because, right, like I said, I've got a lot to tell you pretty quickly. So to be able to do that, I've got to establish a bit of a baseline. So, I'm going to give you a couple things, and I would love it if someone would volunteer a definition for what that word is. First one. So what's a volcano? Yes, John. An earth pimple is a great definition. So, does anybody know a volcano nearby? Thank you. Mount Rainier is what I was looking for. So, an earth pimple, right? Boiling, hot rock, underground, coming up occasionally in catastrophic eruptions. Let's do the next one. What's an earthquake? Sliding tectonic plates. Okay, so we're getting more technical now. Earth pimple, I like that. That's good. Things rubbing against each other, right, to generate a lot of energy and shake the ground in a couple different ways, sometimes tectonic plates. How about a glacier? Frozen ice for like 2 or 3 days. For a while, right? So it's a persistent big snow and ice pack, right? Today, where do we see glaciers? Up on Rainier. Baker and Rainier have a shocking amount of glaciers. If you guys haven't been around in the rest of the country, Rainier, I think, has half of the named glacial mass of the entire lower 48 states. So there's a lot of ice there. What's the difference between a glacier and an ice sheet? What is an ice sheet?
I guess a loading zone would be moving down the mountainside, where an ice sheet is just sitting on a plateau.
So as glaciers are moving and ice sheets are sitting on a plateau. Bigger too, right? Giant, big hunk of ice, larger than your usual mountain glacier. The ice sheet is actually moving too, but it's moving really, really slowly. So is the glacier. Where are there ice sheets today? Greenland and Antarctica, too. Okay. That's bis-2-ethyl hexyl phthalate. That's a joke. So, I got to learn a lot of cool, good earth science. That's what got me into it. But then when you're actually out there working in the industry, these are the kind of crazy critters that you're actually going to have to be dealing with. This is one of the many contaminants that are found in the river right outside. We'll get back to that. Okay. So I lied on the sheet. On your poster that invited you to this event, it says the last 15,000 years. But I'm a geologist. From my point of view, that's the blink of an eye, right? That's really, really recent time. So I'm interested in what's really, really old as well. Okay. So, what What are you standing on today? What's underneath you if you could get through all of the scudge between you and the rocks down below? Hard rock. That's exactly what I wanted to hear. So, here's another fancy word right away. Craton. C-R-A-T-O-N. This is a good science word. It's also a great Scrabble word if you ever have a chance. So craton is the inner core of the continent. It's the deep ancestral heart of the North American continent in our case. It's mostly up in Canada, as you can see from this picture, right? So the big brown thing is the shield itself, the old heart of the continent. What do you think all that other stuff is? Stuff coming in. Yeah, exactly. So that's why it says dust bunnies. I would use this for Geology 101 kids all the time. If you look under your bed at home, if you haven't cleaned in a while, what starts accumulating? Little dust bunnies, right? Dust will stick to dust. If you have a Siberian Husky at home, like my wife and I do, you know this very well. Continents work pretty much the same way. They've got a deep inner core and then scuds that's just been building up on the side for the last 1.5 billion years, right? Very long time. The word terrain is a fancy word for scuds. Terrain is basically just a group of rocks that we can tell formed somewhere together and then maybe moved somewhere else together as a unit. Does that make sense? So, okay. So here's a classic kind of Geology 101 picture of a subduction zone. Hopefully this makes some sense. I'm looking for happy eyes or dead eyes. On the far right, you got the continental crust, right? The initial deep core of the continent. In this case, the picture is showing a thing sort of like the Japanese islands. You guys have heard of the Ring of Fire, I hope, right? Pacific Rim. So all around the Pacific Rim are these subducting parts of the ocean crust. Subducting means that it's moving underneath, right? Continental crust. In the case of something like Japan, the ocean crust is actually going under other ocean crust. So you end up with a line of volcanic islands, right? Does that make sense? You can see in this picture. With enough hundreds of millions of years of these plates coming in, eventually it gets to be like a traffic jam, right? These things are just going to start shoving each other up on top. So I don't have a really good example from Washington State, but here is an example from the state of Alaska. It's the same kind of thing. So continental crust, right, on the far right. Repeated islands and other junk just floating around out in the Pacific, getting shoved up on the side, making these big stripes of terrains. So far, so good? So our specific terrain that we get underneath us is this thing called Silesia. When I was an undergraduate, it was called the crescent terrain, so you might have heard that too, because it's in the shape of a crescent, kind of look at it. So, you don't really see this anywhere in Seattle. This is hundreds of feet underneath us, everywhere, right? I mean, look at how giant of an area this thing covers. It's mostly basalt, so it's like the rocks in Hawaii, right? Dark silica core. It's about 50 million years ago. So, quick quiz, are the dinosaurs alive or dead? They're dead. By about 10 million years, 10, 15. So we don't really know for certain where this thing formed. We know when it formed, and we know when it got here. Does that make sense? So we just see like the corpse stuck to the side of our continent deep underground. Okay? Lopez Island, not part of the crescent terrain, but here's a good example of what basalt looks like. So those are big pillow basalts. So basalt that erupted underwater and cooled very quickly. It's pretty neat to see, I think. You see a lot of this kind of stuff actively forming in Hawaii today. So what else is down there? So this is a little geologic map I made of central Seattle. Everything that's light green are what I would call a young sediment. We'll get back to that. Everything that's dark green is an older sediment. Anybody notice anything on there that's not green? Okay. So, this is one of the things I think is coolest from the perspective of a geologist about South Seattle. Where else do you guys see bedrock in Seattle? Like actual rock sticking out of the ground? Nowhere. Trust me on that. Pretty much nowhere. All of the Northwest has had glaciers just dumping their junk on top of us for 2 million years. So we've thoroughly buried everything deep underground, except at a couple spots down here. So one of those is that orange blob you can see that kind of comes out from Seward Park, going to the west. There's two little satellite blobs actually in South Park. You can see on the west side of the river. There's another little one at Alki Point, but I didn't show it on this map. Sorry, West Seattle. So most of that stuff is a sandstone called the Blakely Formation. It's about 50, obviously must be less than the salt, right, that's underneath it. It's about 55 to 35, can't remember what I used up there, 23 million years. It's got a wide range. Sandstone is just the rock that forms at a beach. Picture every beach you've ever been on. Imagine that beach getting buried and sitting there for millions of years. It's going to be a sandstone. I didn't have any really fun pictures of this sandstone, but I have a chunk if you really wanted to see what it looks like. You know, it's pretty boring. Just a plain old sandstone. Yeah? A lot of great things are made out of. So you said the U.S. Capitol is made out of sandstone? I can't not mention, right, because I went to Western Washington University, the Chuckanut sandstone, right, is up and down the entire West Coast. They used huge blocks of that to build stuff as far away as San Francisco, too. So I'm in no way putting down sandstone. It's just not very photogenic. The other thing that's down here is even cooler, and a thing I'm going to talk about repeatedly today. Those little red blobs, volcanoclastic is sort of a garbage term. But what it means is it's volcanic rocks that maybe broke apart a bit. So it's energetic explosions and or reworked volcanic rocks. You'll see what that looks like in a second. At those little hills, right, you can see at the bottom of that picture, a couple red blobs. Okay. So here's one of them. Duwamish Hill Preserve, I think, is maybe one of the coolest spots, I mean, at least from a geology and from a cultural anthropology point of view, in the entire city. So you can actually see, it's hard to see from back there, but the figure on the right is me running with like boyish glee towards the rocks. So I'm so excited. Okay. So this thing is down, it's south of Boeing Access Road, west of I-5. We'll see it on another map. It's very cool. It pokes right up. Yeah, it's in Tukwila. It's on the edge of Allentown, Tukwila. Just above the bit of river you can see down below me there, right, looking down. This view is looking back towards I-5 and light rail on the right. Okay. So pretty unremarkable picture, right? Here I've been putting down sandstone, and this picture doesn't look that exciting, but it will in a second. This is at Duwamish Hill Preserve Park. There's two really cool giant rock formations that get exposed there. One has a bunch of fossils in it. There's a marine fossil layer kind of to the bottom left of this picture. The stuff up on the top is a flow sheet of about 35 million year old lava. Once upon a time, coming out of the ancestral cascades. There were big lava flows that came out of the hilllands, kind of made it that far. Go to the next one, if you would. So this is right back up in Whatcom County again. This is on the way up to Table Mountain or Artist Point. You guys ever heard of that? Up past the Mount Baker ski area. So what's going on there? It's the same sort of thing. Once upon a time, big thing of lava flows out of Baker, makes a big sheet, and cools. And when this type of volcanic rock cools, it cools in a cool way. It cools, making columns going down. So basically on the top, you get a bunch of hexagon shapes, interlocking hexagons, and long columns growing down from where it's coolest towards warm. Does that make sense? So in the case of this thing that my one-time geology professor is demonstrating, it actually flowed off of a surface. That's why it's got that differential bend in it. Does that make a bit of sense? You can see they were at flexures right in the middle. So, same old boring picture again, geez. Unless, maybe we'll get closer and closer to it, and you see the little hexagons on the top. I've got a little pen for scale, it's a Pentel pen. And you see the little hexagonal and square shapes locking together on the top, because the sheet of lava made it right to there, and then just cooled, stuck in the front, right? So you're actually looking at the front of a flow that got stalled out right there. Maybe coming from somewhere as far as Issaquah even, right? These are really long flows, and none of the back end of them is still preserved. That's pretty cool, yeah?
Is that the whole petrol formation? Is it this kind of volcanoclastic?
So remember when I said volcanoclastic is a garbage term? That's why they use it. It's a whole bunch of different things. So sometimes it is this really beautiful, well-preserved flowing stuff, and other times it's stuff like this that somebody then kicked apart. And it's just like loose, almost like a glacial sediment. That makes sense? Yeah? Correct, yeah. So basically, any time that you have flowing molten rock that isn't the salt, you're probably going to get these things. It's the same erosion. Anything else? I'm going to have points too where I'll explicitly look for questions from you, but yeah.
Near the Duwamish Preserve, if you go through the airport way cut there, there's some of that same kind of rock, but it's a little different. It's not maybe as garbage, like in the but in a book that I'm at the Historical Society, but in a book that we wrote in the beginning, it was kind of close to igneous, and there's striations, this white calcified striations. What would that be from? Would it be characteristic of being near a mountain?
I don't know, but I know exactly the striations that you're talking about. It could be anything, right? It could be something from back when it first went down, and maybe there's an inclusion of something else that's melting down on the rock. Could be something that happened in the 30 million years since, right? I've never actually hit at that rock, so I don't want to say anything about it. But what he's talking about, right, is the turnaround, right, next to Boeing Access Road. The light rail goes pretty much right through it. It's a cool spot. And we're going to come back to that spot over and over again. Is that good for now? So bonus round. Where the heck is this? So, that's good. Big, massive gray rock, a bunch of red, hackly rock on top of it. And you can just barely see in this picture, in the foreground there is a sewer grate. Can you see that? So this whole thing was, until very recently, a parking lot. That grate was a storm drainage for the parking lot. And they've ripped up everything else. Columbia City. It's the middle of Columbia City. It's where they're putting in that new PCC. I don't know that they expected this much rock when they were getting ready to build this thing. Because these poor guys were out there for weeks and months with big rock pounding stuff. That's really hard to get through. And not a thing you expect to hit if you're building in Seattle, right? We've all gotten very lazy and used to getting to dig in some till, or sand, not solid rock. So it's under there, you just gotta get down to it. Okay. So any questions? Any questions about that before I go on? Super duper. Oh yeah, yeah.
Are these rock formations all left over from glacial flows or something?
Pre. These are all before. So yeah, this is everything now that's underneath, and now we're going to put glaciers on top of it. Good? Great. Okay. So MA and KA. MA means millions of years. KA means thousands of years. So you can read that as the Pleistocene, which is a time period in Earth history, goes from 2.6 million years ago to 11.7 thousand years ago. So pretty far back to pretty recently. The story of the Pleistocene is that we've had repeated glaciations. Over and over again, massive ice sheets have built up on the northern continents especially, and then advanced all the way down, and then melted back, advanced, melted back, advanced. 15 times, 20 times, something like that are the numbers that I see for how many glacial and interglacial periods. But the problem is, if you think about it, a glacier is like a bulldozer. We'll talk a lot about that, but glacier's pushing everything in front of it, right? Trashing the landscape. So is that going to preserve a lot of records from all the other times it had been there? That makes sense. So every time one of these things comes down, it just wipes the slate clean again. Okay. So here's a picture of a current ice sheet, and I picked this one because it had a nice, what looks like a stratovolcano in the background. So it's kind of what we maybe could have looked like here. And then here's a big Earth map of around the last glacial maximum. It's about, depending on where you are on the planet, it's between 20,000 and 15,000 years ago. Part of what I wanted you to get to see on this thing, you can't read them, I'm well aware of that. But, do you think that it has the Sahara marked as desert on this map of climate types? No. Do you notice anything else kind of goofy versus our current world? Big lake in the middle of the country. There'll be big lakes around here too when we zoom in a bit. How about Alaska? Could Sarah Palin have posed a viable threat to Russia if she was alive at this time? So that's the famous land bridge, right? There's Thuringia connecting Siberia to Russia. So here we are zoomed in. Here's your big lakes again, right? So, big lakes down near Utah, big lakes in Montana, Wyoming, basically places that these glaciers could impound rivers that already existed. And what else do I want to point out here? So you can see Cordilleran ice sheet is the fancy name for the ice sheet that was around here. Puget Lobe is this big tongue-like shape of it that stuck its way all the way down into Washington State. And about as far as Olympia-ish. Here's a movie. Don't trust me, trust this movie. So 20,000 years ago, we've got kind of watery lake inside where Puget Sound is right now. Is it actually? So now it's starting to make its way down from the north, right? Hopefully. This is from Utah. Pack Roads, at least one. So now it's made it past Seattle, hitting Tacoma. The brown stripe in the front of it, you think about this massive thing of ice, it's always flowing forward, right? So it's also carrying water with it forward as it goes. So it makes like giant deltas in front of it. We'll come back to that. So that's about max. Now it's retreating, 16.9, 16.7. Now what about all the rivers that would have been flowing to Puget Sound at that point in time, right? You see how those giant lakes start to form. There's no way out. There's no outlet up at the Duwamish Strait. So I especially like this little video because it shows a couple fine details that are important. Look between Seattle and Tacoma there, those top two black dots. Doesn't it look like there's an island between them? So where the Duwamish Valley extends further south, there was a big marine embayment, is the fancy name. But basically like the Sound, right? Like another tongue of the Sound, like Hood Canal is today. But it got filled in, right? As stuff came back. Okay. Jump away. So 3,000 feet thick of ice in Seattle, about 5 Space Needles. You can't have that much stuff on top of you without it profoundly affecting your landscape, obviously, right? So bulldozing, polishing stuff off, ripping stuff apart as it passes by, okay? Shaping things. So if you look at a map of Seattle, you ever noticed all our north-south hills? Not a coincidence, right? That's the direction the glacier is moving along, so it streamlines everything down. It's called a drumlin. Roche Mountain, we don't have a lot around here, but in the San Juans, you'll see these smoothed off one side of the hill, rough back end. Okay? So here's some pictures, because it's nicer. So there's a pretty great example of glacial polish from BC. This one is from up near Mount Baker, and actually also has things called chatter marks, where it will rip little peeps off of the rock, right? One cool way you can check for this kind of thing is run your hand across it, right? See if your hand moves the same way forwards and backwards. A lot of the time, if it's glacially polished, you'll be able to run it one way, but the other way will be rough. Pretty obvious sign. Okay? So what gets left behind from this massive thing of ice carrying all this other junk with it? Advanced outwash, I already talked about, right? So those are the deltas forming on the front, falling off the front face. Glacial till is something that anybody who's a gardener probably hates if they live in the Seattle area, right? So glacial till is just, I've used this word a lot today, but it is the junk that the glacier is just pushing along with it. Just a loose mix of big pieces, little pieces, chunks of rock, solid rock this big, down to clay that you can't see, with kind of no rhyme or reason to it. Moraines are usually made out of till, and they're features on the sides or end of the glacier. So the glacier will smooth out the sides and leave pillows where it's been, and it'll leave a nice little pillow at the end as far as it gets before it retreats back. I'll show you a picture that'll make a lot more sense. Erratics. Glacial erratics are those huge boulders that get left behind. No other way you could have transported a 15-foot boulder to your backyard, right? Something moved it there for you. I've never done that. I believe almost everywhere. Where is it? Yes. It must be. Yeah. There'd be nothing else that would move stuff. There's the channeled scaffolds that move boulders, but it's not for us. Glacial marine drift is the last one. Remember how I impounded up at the Duwamish Strait, right on the north end of Puget Sound? As the glacier makes its way back, eventually it starts letting the ocean in. And you get, just in case there wasn't enough just loose, random stuff hanging out, now you've got the ocean coming in too. So it looks kind of like till usually, but has more clay. Sometimes it has little shells in it, is what I will look for to try to tell it apart. I'll show you a picture. So I didn't just include that quarry picture for fun. This is a quarry outside of Anacortes, near Highway 20. You can see the rhythmic bedding, right, on those outcrops going up the side. This is an advanced outwash thing. So every time there was a big water event, this thing was leaving new successive rhythmic patterns of sediment. Okay. Here is looking down from near Mount Baker, where one of its glaciers used to be. So these are moraines. On the right side, one of the side moraines called lateral moraine. You can see too on the bottom, it almost looks like rock, but that's till down below, just loose, hackly, lots of big pieces, lots of little pieces. And you can't quite see it, but in the distance there's a darker shape, kind of at the end of this tongue shape. That's the terminal moraine. That's the farthest that this glacier's remained recently and left a little mark of where it had been. And then glacial marine drift, this is just my picture to show you that it's just big, massive things of clay that sometimes have little bits of shells in them. This is to Dead Horse Canyon, but the real name is Taylor Creek, or Lakeview Park, I think, like Ridge. It's Dead Horse Canyon. You can see some more little tiny rhythmic patterns on the very bottom there. It's hard to see, I know. But just above where the leaves end, there's some tiny little beds that are about 1 centimeter tall. So that's that glacial marine drift again, right? Big tide events coming in and out. Okay. Can't put that much ice on top of yourself without taking water out of the ocean, right? So during these glacial periods, a lot more water is up on land, so sea level is lower. So sea level starts rising when you melt the glaciers, right? Same thing we've been worried about with the West Antarctic ice sheet today. Okay. Also, you can't put that much weight on top of yourself without weighing yourself down, right? So at the same time that the sea level was coming up because stuff was melting, the land surface was also coming up because it didn't have this giant weight on top of it anymore. Does that make a bit of sense? So there's places in the world that have had their ice taken off more recently where you can see this very, very dramatically. England is an example. Parts of England, the north part of England is rising. I might be mixing these around. You're not English, so it's okay. The north part of England is rising. The south part is sinking down still, which causes troubles, right, if you're already worried about sea level rise in general. So here's what we ended up with. I tried to color these slightly differently, but basically, all along inside, it's alluvium, which is just a fancy word for stuff left by rivers, and artificial fill, which we'll get back to. Up on our hills, we've got a mix of both the recessional deposits, which usually are big things of sand, and then almost all of the hills are capped off with a till. So we have hard clay on the top, then some sand, then maybe some clay, then maybe some sand, right? You've probably seen it if you've gone to Discovery Park, looked at the bluff. You can see alternating layers in it. Okay. Obviously, this is the only place I found to shoehorn landslides into this talk. Obviously, that affects where we're going to get landslides, right? So, how quickly does water move through sand? Pretty fast, right? How quickly does it move through clay? Not so great. So, if you have a bunch of sand, and then underneath it a bunch of clay, and you cut a cliff face through it, what do you think is going to happen as the water goes down through that sand? Yeah, it's just going to bounce right off the clay, right? Start coming forward. That controls almost all of the landslides that we have in the Seattle area. It's always the same 2 or 3 deposits where the clay occurs and it'll start running out water on top of it. This picture on the right is Lake Ridge Park, side of Taylor Creek. There are a ton of debris slides right now. I was there about 2 weeks ago, and just the whole right bank of the creek is trashed from all the big rain events that we've had. So that is a debris slide like 2 or 3 days after it occurred. What I noticed looking at that slide is it's a bunch of clay, right? So it's come through the sand and then grabbed clay off the front as it tears itself forward, which should make sense, right? If that's where it's getting stuck. The picture on the left was from that recent really scary UW paper that pointed out to everybody that when we have an earthquake, we won't just have an earthquake, we'll also have a bazillion landslides. That's maybe an exaggeration, but it's an order of magnitude. We know it's going to fail all along those hillsides, right? Anywhere you've got those kind of deposits, if it's in the wet part of the year, it's going to go. I don't feel like I even need to qualify that statement. Okay. Any questions on that? We're coming up on break o'clock, about 15 minutes. But yeah, James.
When you talk about the landslides and those type of things, and you say the trash is, what that's there, but isn't that also incredibly necessary for how the earth actually works with all kinds of species?
So I took a lot of pictures that day to show exactly that. I've got pictures of the debris slides where they enter Taylor Creek, and you can see where it's feeding the sedimentation of the creek. The one thing I'll say though too, I use the word trashed, which I realize sounds judgmenty. I believe that some of the slides were off properties that had their vegetation stripped. So I think that in at least a couple places there were new flow channels made by clear cutting, for example. It's unexpected. So to me, that's not a natural system, right? But anyway. Yes. Anybody else? Cool. So the natural state of the rivers post-ice. So it was like a new land, right? After the glacier goes away, you've got just this barren, heavily reworked landscape waiting for new modern rivers, new landforms, right? So, okay. This slide is to show something kind of cool. It's going to be hard to see at a distance. I apologize for that. Puget Sound, our topography is pretty even, right? There's hills down here, but it's nothing like if you go to the Cascades. Correct? Do you agree with me there? So, the way a lot of these rivers grew up, right, the way that they ended up developing, was based on both what they were cutting through and what kind of valley they were coming out of. Okay? So, for example, that B and the N are two cross sections, so side views of a river. Okay? B is what a river probably kind of classically looks like in your guys' heads, right? So, a natural river system, you got a fire hose, right, of water and sediment going out over some big plain, big flat area, and can kind of just wave back and forth, right? Whatever's the easiest way for it to get downhill eventually. So as it does that, it builds up natural levees, right? We don't even have that many natural levees for you guys to look at anymore in the Northwest. But you can imagine, right? Goes this way, builds up a pile over here. Goes this way, builds up a pile over here. And eventually makes itself a big, nice floodplain, right? That's one way we make rivers around here. The second way is that second cross-section, letter N. 2 million years of glaciation is a lot of years of glaciation, right? We've had a whole lot of these events occurring over and over and over. So we've built up a lot of stuff in a couple places. So either you get a nice river spraying itself out, making a floodplain, or you get a steep gorge, right? So that's the steep gorge model, where it's got older built up stuff on the sides, and now the river just acts like a buzzsaw trying to cut its way through. You end up with something on a different scale, but kind of Grand Canyon-y, right? Steep, narrow. Okay. Another thing was building the rivers at that time, and those are lahars. Play this little one. So play it again. So lahars are one of those science words that people in the Northwest know that other people might not know. It's a volcanic mudslide, right? It's a big, giant threat. It is the thing, if you, anyone in this room, were to be killed by a volcano, God forbid, this is what would actually probably kill you, right? You picture yourself dying in a lava flow or an ash cloud or something like that. But these things make it dozens of miles, right? Next one. So this is a really long video, so we'll just watch a little bit of it. But this is 2007, and it's Mount Apu in New Zealand. It's a pretty much identical stratovolcano, same kind of deal. And it had a catastrophic lahar. And you can see that that is not a good thing.
Because the water in this video here is also from glacial release water.
Correct. Yeah, so thank you very much for mentioning that, right? A lahar should make sense that it has a lot of water and mud, right? What did we already say is all over Mount Rainier? Like more glaciers than anywhere else, right? So put a bunch of hot fluid, hot rock underneath that, kablooey. You can see, the reason I like this video, although you can't see where the normal river would have been, you know there's a normal river underneath that, and you can see that it's nowhere near the banks of where that normal river would have been. Right? I mean, look at the sediments, you can see it going through. Jump to about 4 minutes. Somewhere in there. This is 2007. A little bit more. It usually gets cold pretty fast, I believe. So yeah, it doesn't look like the normal load for that bridge, right? Jump about a minute and a half. Yeah, here we go. So now you can see really clearly where the normal river channel was supposed to be, right? There's some kind of levee or natural levee that had that row of trees on it. But it's such a just massive volume moving at such speed that there's no way it's going to constrain itself to the river channel. This is what should keep boarding up at night.
They got 2 lanes in and out.
Yeah, that's right, that's right. That's better than some of the coast communities. Okay, thanks. So, right, remember that big marine embayment? We had this big arm of Puget Sound working its way all up into the valley. That's not there anymore. And it's because Mount Rainier had a couple whoopsies and kept just extending out its sediment pile, right? would just fill in that whole channel with these huge lahar deposits. Okay. So this is the way it was. And this will be a good stopping point too. So I tried to colorize these just a little bit. It's looking down into the Duwamish Valley, circa 1899, from a ways away. We would be off this map up near the word black, right? The river Duwamish keeps going that way. But so, you got the Cedar River coming down. Lake Washington is draining out to the south, right, through the Black River, which joins the Cedar River. Cedar River joins it. They both flow into the Duwamish. Down here where Fort Dent is, they're also getting joined by the White River, right, which comes in, goes north through that long valley, connects them up there. And the Green River connects to the White in the extreme southeast even, right? That's the only part that we call the Green River in that picture. So that's what we had. Next one. So go to the back. Take a moment. How 5 minutes probably?
Yeah, exactly. Restrooms are right up the exit to the left. There's fresh coffee. Back.
Is that the right button? Is that how it should look?
Is this on?
We're going to do it then.
So welcome everybody. My name is Ken in the Shukti, the native language around here. Work with Giants. So we will introduce ourselves. So Giants don't start. My name is Ken Workman. I'm of the Duwamish, I'll take the Duwamish, and great Miss World, grandson of Chief Seattle, so that would be Akwaye, Seattle. We hit Dr. Seattle, welcome everyone to this house. I'll tell you too hot, a long time ago, but at the end of they started as that was a long time ago. Everybody knew this language, Duwamish. And pretty too hot a long time ago. I think we'll just leave it at that. So what these sounds are, it's pretty thank you. These sounds are ancient sounds, and they haven't been heard here for a long time. So that's my own personal mission, is to bring all this stuff back. And so when we see these things up here that say 15,000 years ago, and the first people, what do the first people look like? Well, they look like Cecile. They look like James back here. James, will you stand up? Hey. And they look like it all of us. So my point in all of that is that we talked about the glaciers here, the glaciers receding, and we have tales in Duwamish about the cold and the hot, and they fought and they warred right down here. We're at the Duwamish, at the south end of Boyne Field on the Duwamish River. There are rocks in that river. And this is where that great battle between the north wind and the south wind fought. And the south wind won this war. So we have tales of the receding of the cold, even here. So with that, I'll just say, Asquedidavcha, thank you. Bisiaya, Paul, Ibash, Asquedidavcha, Tukra, Pea, Tutuavus. Thank you, everybody, for driving through here to this place, Duwamish.
Everybody settled in? Good. Okay. So we're coming up, remember, on my second paranoia. So, right, tutor at a high school. Anytime they bring me a psychology or sociology, biology questions, I try to make very clear to them where my specialties are. They're not in those things or in cultural anthropology. So please, again, bear with me. Hey, I remember this slide. So, last glacial maximum, right, about 22,000 years ago. There's Beringia, the big land bridge, the land that doesn't exist anymore between Alaska and Siberia. So that's probably how people got here, right? First peoples. It's still a little contentious. Get back to that. But not contentious at all are the Clovis culture. It's pretty obvious that about 13,000 years ago, everybody in a huge part of North and South America were making their tools the same way, right? Which seems pretty indicative of a pretty rapid spread of one group of peoples and their technology. Extremely fast. Back to that again. It's marked by basically just a two-sided spear point, right? So the way they identify something as belonging to the Clovis culture is looking for these characteristic spear point creation styles and tools that they would use to make them. By about 9,000 years ago, it gets a lot more patchy. There's a Folsom tradition. There's a couple other traditions that look like evolved from the Clovis people. Something happened to make it a lot harder for the Clovis to keep living the way they had been living, and it's not clear what that is. Could have been overhunting of megafauna was a pretty popular theory for a while, but also it looks like the climate was just changing in general. So either a lot of the cool mastodons and camels and stuff were hunted to extinction, or they just died when their land went away anyway. Does that make sense? So, I can't speak to either one of those. One thing that I think is cool, and there was a bunch about this just recently, so we can look at spear points and tools and say, oh, everybody was using these same tools, so probably they knew each other. But an even better way to say that authoritatively is looking at genetics and looking at how the groups of human populations have shared genes or not shared genes over the last hundreds of thousands of years. And it looks like the genetics tell almost exactly the same story as the Clovis technology, right? That everybody on both continents stemmed from the same ancestral population groups about 12.7 thousand years ago. They have a common ancestor, basically, which is a big point in support of everybody coming over together at once, right? Does that make sense? It's about 80%. That extra 20% in the genetics are people going back and forth across the land bridge. So in both North and South America, the indigenous populations that are the least similar genetically are the people who live in northern Canada, for example, because they were probably going back and forth, or at least hanging out in Beringia that doesn't exist anymore. Does that make some sense? Everybody came in one big pulse. Some people hung out at the top and went back and forth for a bit. this. The Duwamish, right? So there's sites that have been occupied. I think Herringhouse was from 6th century AD, so about 1400 years ago. Stuff up on Discovery Park, I think goes back to 4000. Where's Ken? So that's a long time, right? It's not 13, 12,000. But for the fact that the Duwamish and other people around here have kept oral traditions that seem an awful lot like tales about the end of an ice age, right? So that cool Duwamish Hill Preserve Park that I think is so cool, and hopefully you will too, that spot and the rocks across the way with the big white marks coming down the front of them both feature in important, call them origin stories, for the Duwamish about how the land was even made livable. And it's much more convoluted than I can say, but the short version that I understand is boy growing up to be a man, becoming warrior, helps fight off North Wind. North Wind is this oppressing spirit. There's ice damming the river. Salmon can't get up. The boy becomes or works with storm wind or south wind, right? This opposing force that thaws everything out, breaks the ice dam down, makes the land livable. Doesn't that sound an awful lot like that little animation you saw earlier of the big ice sheet coming down? I sure think it sounds like it. But, go ahead. So here's about where they were. I'll come back to that in a second. I got a second point for that. This is from that coastsalishnmap.org, which is a pretty cool website, at least from my point of view. We talk a lot about the Duwamish, but the Duwamish were the people of the inside, right? We're also a lot of communities, affiliates on the lake side, people of the large lake. I cannot pronounce any kind of Coast Salish words or language, so I'm going to stick with descriptions of what the words mean. I hope that's okay. You can find out a lot, obviously, from Ken or even back there. But so a couple, prominent spots. Little crossing over place, about where King Street Station was, big central population hub. Herringhouse, right? Pretty much more or less where you are across the street. Terminal 107. Basket Cap, right down here as well. Tide Flats was another big community near here. Lots of people down where the Black River was. Okay. So, maybe you don't believe me about they could possibly preserve a story for 12,000 years about when they last saw the ice sheets. Which, okay, this would be pretty impressive. But for this kind of cool bit. So here's another kind of geology 101 map, right? This is the Cascadia subduction zone. The big, totally terrifying earthquake that everybody is scared about is this thing called a mega thrust earthquake. It's got a great name. So mega thrust, subducting plate coming down, right, underneath the continent. Usually, rocks can kind of slide by each other when you're thinking about them on these massive turns. But, this would be hard with the microphone. Can you tell I'm a kinesthetic teacher? Subducting plate, continental plate, where they touch, get stuck. So we'll pull that tip down a little bit. Pull the tip until it snaps back. So that's what those two pictures are showing you. Top picture, plate is getting its front toe pulled forward. Second picture, plate snaps back up. And remember that the subduction is happening off our coast. So when it snaps back up, what's on top of it? You have the Pacific Ocean, a ton of water. The subduction zone runs all the way along our coast, right? I mean, from like Tofino down to southern Oregon, at least, Northern California. When it snaps, it looks like most of that entire line snaps. Like, it's not just snapping in one little spot, it's snapping the whole coast. So that can move a lot of water, right? That can generate a ton of energy. And it has, unfortunately, in our lifetimes, not this one, but anybody know an exact parallel to this horrible fate that awaits us? Circa 2004. Well, Indonesia is what I'm looking for. So Japan is another bad sort of thing, but Japan probably was similar, but it's not as large of an area. The Banda Aceh, right, the huge Indonesian tsunami, moved a similar kind of 90 to 100 mile stretch of subducting coastline. And it snaps it up immediately. I think it was 10 meters of offset. So 100 miles times 10 meters is a lot of energy. It's a really bad day. And it obviously was a very bad day, right? Boxing Day. Okay. So there was this big pat ourselves on the back cool study from a couple of years ago from the USGS where a guy named Brian Atwater, especially working with different sorts of earth scientists up and down the coast, they kept finding really similar stuff. One of the things they kept finding was along the coast, these huge sheets of sand that would run their way in for miles even sometimes, just on top of everything else randomly. Add that to stuff like a drowned forest, right, where you find a bunch of intact trees that for some reason are now under 15 or 20 feet of water. Eventually it starts looking like you had a massive earthquake, right? Something giant happened over the entire coastline. The cool pat themselves on the back thing is that eventually people were able to figure out, both from carbon dating trees that got killed and looking at when those sheet deposits land, and tie all of that together with a tsunami that hit Japan 300 years ago that the Japanese took careful records of, right? This and that day, all my boats were destroyed. To find out that this is the last time this horrible thing happened here. Specifically, 9 p.m., January 26, 1700, a Tuesday. So you can get that kind of thing, because, right, tsunamis travel at a predictable rate. They know exactly-ish when it hit Japan, so they can just back it all out. Sounds like a hard job, right? Sounds like a lot of work. So maybe we should have just asked these guys. This is from a paper, Full Brush. So he's a history professor at the University of British Columbia that wrote 2 neat papers that I'm indebted to Justin for pointing out to me. One of them was about finding fault. And it starts with that same story I just told you, right? Earth scientists find out about the megathrust. They think it's so cool. They think they're really cool for working out this detective story of when it happened. All of those little dots are oral histories that seem like they're describing a megathrust that Professor Thrush found up and down the west coast. Oral histories that basically describe tsunamis, describe forests getting drowned, minutes of shaking, everything you would expect, right, from an oral history of a giant earthquake and tsunami. What's even cooler, I know you can't see anything on that, but what this table is, you can even date them, right? Talking to these people, they were able to talk to surviving tribal members and count back from these people's stories. Oh, it was about 7 generations ago. Oh, okay, that's this many years, this many years, this many years from that start date. They all land within the margin of error of that 1700 quake. So, I mean, it's not telling you 9 p.m. January 26, 1700, but it is an amazing amount of specificity, I think. You can't see it, but trust me, those little error bars, very, very tiny, right? Putting all these stories together, statistically, you can say, yes, probably something happened then. So I think that's awesome. So contact, a long sad story I'm glad I only have to tell part of. There are other people here who know much more than I do, including this building itself. So I would strongly encourage you to avail yourself of those resources. But I can tell you a little. Oh, any questions about First Peoples or earthquake before I go on to megathrust? Oh. So contact, right, is the story of how you go from this to this in about 10 years. There's actually a picture I saw out here before this talk of Salmon Bay Charlie getting evicted from his house in 1913. So literally the picture between those two is out there. So what, obviously this is the locks, right? There's the Chittenden locks getting built. Okay. Here is a bunch of Europeans get here dates, right? So Vancouver, scoping the scene ahead of everybody else. Denny party, landing at West Seattle and then giving up and coming inland. Platte in the 1850s. It got incorporated twice. The city of Seattle got incorporated once, and then there was some violence. It got de-incorporated and then reincorporated. But the one that stuck was 1869, when they had about 1,000 people. But from 1869, 1,000 people. By 1884, we've got streetcars. By 1888, we've got anti-Chinese riots, right? So my point is, 40 years, the city grew unbelievably quickly once it started building, right? Once the stakes were in. And then the big fire in 1889. So here's a view from King Street Station, once upon a time, little crossing over place, looking north, I think. Right, baby city getting born, still. Okay. So everybody has always seen that picture from the Denny regrade, right, where there's that one little house that's up on a hill and they've thrown everything else up. Here's the deep. I went with Dearborn instead. So this is south of the International District, right? Probably this picture is from right about where Goodwill is now. That means anything to you guys. So looking towards the Jose P. Rizal Bridge, 12th Street Bridge. So they had a lot of big schemes, right, for ways they thought they could improve this natural landscape that they got. When you do this kind of thing, right, when you destroy a bunch of hills with hoses and dynamite, what do you end up with? Whole lot of mud, right? Just tons and tons of mud and dirt. So where do you think they put it? So, right out here. The other paper from the guy from UBC was about the city of changers. Sort of the idea that these It's about a lot of ideas. But European engineers reforming the city in their own image with no consciousness of basically viewing the natives as, I'm not saying an obstacle, but I would say as incidental as the plants or dirt that they were shoving around at the same time. Very, very poorly, right? As a result of their mindset. So this picture is in that paper as an example. I think it's a pretty good one. The paper uses words like tautology a lot. I had a quote, but I took it away because I don't want to use the word tautology. So this is an ad from about 1910. And what do you see when you look at this ad for the tide lands, right? This new land that they're building with all the dirt they're shoving into the end of the river. Smokestacks. The paper used the word belching smokestacks. So way out on the horizon, right? There's progress and industry coming into the city is what this is psychodynamically trying to show you, right? So belching smokestacks represent the advent of modernity, and they're pushing the natives out, right? That's the other psychodynamic message from this thing. The natives are outside, right? Peering in. The vanishing natives was one of the terms that this paper kept using. That was their idea. They're just pushing people to the peripheries, which they literally were doing, right, as they would build properties or structures. Okay? So there's all that dirt, right, ending up in the new industrial zones that they're building at the end of the river. Okay? So, can't really tell if this is a backwards picture. I can never really tell which way it's looking, but it's near the end of the river at that time, right? Filling in tide flats. Just trucking stuff from these regrades, dumping them in, not doing a really good job of consolidating it, right? Or making sure that it's really stable land. Yeah?
It looks like Harbor Island was built in.
Right. Yeah. So Harbor Island is the key example of that. One time the largest man-made island. And I think that is the start of Harbor Island. I think you're right. Yeah. Okay. So, with that same kind of European mindset, I think, comes delusions of grandeur sometimes. Because it really seems like, at least the way they decided to do these things or prioritized projects, was sort of a big man syndrome. Right? Like these big personality guys that think they have this great vision for how the city should be in their image. Chittenden is basically demonized in that UBC paper for exactly those kind of things. I can't remember the exact quote, but there's quotes from Chittenden just mocking people for worrying about stuff like the Black River going away, the level of Lake Washington changing, all these people. It's that they're too emotionally attached to the scenery of things. This is one of the quotes. It reads like anti-NIMBY quotes, not in my backyard stuff, but really the guy is just saying it's natives whining because they're attached to the way things were and they should get out of the way of progress, in almost exactly those words. Gross. Anyway, Chittenden was the Army Corps guy. Thompson, Reginald Thompson, who also set up the Cedar River watershed, right? You can thank him for your delicious water, was a city of Seattle engineer. And Semple is weird. Semple was a former governor who then later in his life had this big plan for how Seattle would be a world-class city via dredging, changing the lake level, making a navigable waterway out of the Duwamish and out of the way to Lake Union. Okay. So I thought this picture was really funny. Thompson, it's funny, all these people had to be part engineer and part evangelist, right? So Thompson has this idea, oh, we're going to make this great new industrial land. It's going to make us a beautiful world-class city. Everybody moved down there. Everybody moved down there. So it was a big victory for them when they got Sears, right, to build their big building down there. Maybe a little prematurely, as you can see on the size of this picture. About 1916, I want to say something like that. Yeah. So Duwamish Waterway Commission is Thompson, big city engineer, wanting to make a navigable waterway. The actual straightening of the river itself is 1913. Took about 7 years. The benchmark they hit was that by 1920, they had made it 5 miles down the river to 50 feet, I think, 4.5 miles to 50 feet. Worth noting that 1920 is the same year that Wattle, I think, old Indian George was starving to death right here, right? So, right across the street, yeah, I mean, but in spitting distance. Yeah, so 1920, all hail progress in society, and we're having people starve to death across the river at the same time. It's weird to me. Okay.
Please explain what that 50 feet to 4.5 miles is.
So actually go back. Yeah.
50 feet to 4.5 miles.
So to make a navigable waterway, it needs to be a predictable depth, right? So that's how far back they had dredged and straightened it. Yeah. So the question was what that meant. So, the same time that they're tinkering with the end of the river, right, the waterway itself, a lot of wacky stuff was going on back up at the headlands, right, on all these other rivers. So, and usually they were flood motivated, right? So we've got new settlers moving to these places like Renton, Auburn. Make yourself a big farm, it floods. The solution isn't move, the solution is I'm going to fix this river. So that's what they did pretty much, right? So in 1906, there's a huge flood in Auburn, Puyallup, I believe, further south. Already there have been farmers kind of tinkering with the White River, trying to divert some of it to their fields, right? After this huge flood, they have a breakthrough, and the White River starts going out this thing called the Stuck River, going down to Puyallup and out towards Tacoma, right? So White River, goodbye. Doesn't come back up this way. And actually, even in the 30s to 40s, yeah, they built Mud Mountain Dam to really absolutely ensure that the White River is not coming back this way. So Mud Mountain Dam at one point was the largest rock and mud freestanding structure in the U.S., maybe on the planet, something ridiculous like that. But a 450-foot tall dam to stop the White River from coming this way anymore. 1911, that flood is in Renton, kills a bunch of people actually, I think, killed a lot of people in Renton. As a result of that, they decide, well, can't have that anymore. So they build their own tiny little waterway, sort of along the side of Boeing. If you guys drive along this part, you can tell it's an engineered river pretty easily. But to make the Cedar River go towards Lake Washington, right, instead of connecting to the Black anymore. And then in 1916, the locks are finished, right? We saw that picture from 1915. It was almost done. 1916, the lake goes down. When the lake level goes down, it doesn't feed to the Black River anymore, right? So the Black River is abandoned. That's all I want to say about that, right? But so Black River doesn't go to the Duwamish anymore. It's the short version. The Duwamish is getting a lot less water than it had been. This Green River also, too, by the way, occupies the old channel of the White River. That's why it's a Green River Trail, okay? Not a White River Trail. Okay. So any questions on that? I drink some water.
Yeah.
Yeah, the Black River is still down. Rather than
time of year, as a matter of fact, the next few months, we're going to start migrating that down and it's going to become very much alive. So, the Duwamish, we live down there on the back end of that, very important to us. Everything Devin said right here is spot on. Real good, Devin.
Thanks, buddy. It's the Black River Riparian Forest, right, is the park that's on the side, and it is really cool down there. If you don't mind the coal mine and construction company up top. Yeah.
Where is that exactly that you guys are talking about?
So it's northeast of South Center, is one way I would say it.
It would be just north of 405, just before it intersects with I-5. So, Google Maps, you'll find it right there.
Green
Monster Road.
Yeah, Monster Road.
Monster Road, just north of Monster Road. This path is right there that walks the path.
And the mouth of the Black River is on the west side of Fort Kent. Still actually.
So there's a blue heron reserve, and just in general, a lot of migrating birds come to that forest, and it's pretty cool. Okay. Okay. So modern times, or dilution solves nothing. So they built a lot of stuff in that industrial land, right, that they suddenly had available to themselves, and with easy shipping right there. So within the sort of watershed that feeds to the Duwamish, or in the Duwamish itself, excuse me, there's 208 pipes, creeks, or discharges, about 203 of which are public, I believe. At least 12 of those are a thing called a CSO, and we'll come back to CSOs again later, but it's a combined sewer pipe. 32 square miles of drainage, and then this list of, so I didn't have to pick myself what I thought was especially bad. I used the EPA's list of the industries that occur within the Duwamish watershed, which they went with shipyard operations, manufacturing, airplane, cement and chemical, cargo storage and transport, metal manufacturing and recycling, petroleum storage, disposal of waste in landfills. Can you think of any others, James? What would you add? Anything good? Yeah, okay, good. Good. Metal manufacturing and recycling sounds like a great, nice thing, but it's worth noting that, from my perspective again anyway, a significant source of metal pollution, both in air deposition and just chunks of stuff falling off. So, okay. So, probably not surprising, this is again from the EPA's Superfund report in 2013. Within the drainage basin, 169 confirmed or suspected contaminated sites, 18 of which are under some version of agreed orders with the State Department of Ecology. An agreed order is basically I'm either cleaning it up within regulations just like you say, or I'm doing this slightly different thing, but I've gotten you to agree to it, right? So they're like enforcement orders that they have to work with the Department of Ecology under a couple different regulation schemes. And then 8 are under some kind of EPA cleanup process. Yeah?
The EPA is any kind of standard pollution control for the waterway, for all these industries, for all these polluting stuff that's happening in our river, along the river?
Yes, yeah, and
When did that happen?
I don't know when the EPA got here. I can't say that. What would you say?
Not only EPA, but also the Department of Ecology, the City of Seattle, and King County have been doing industrial stormwater permits on the Duwamish River for and the enforcement is not as stringent, but they try to do work with the businesses. And in some cases,
controls have been in place for a long time.
Correct. And
So
so
I read about it too, and, nothing's really happening about it.
the water quality in the river is much better than it was.
What does?
It's the sediments in the river that you see from the subsurface.
That list of industry was both current and historical, for example, right? Now, the biggest concern now is the stuff that's already in the dirt and muck at the bottom of the river. Yeah.
I just wanted to add to what James was saying. I'm an engineer that worked here for 30 years. We also, under NPDS, are supposed to monitor our own outfalls and stuff. Boeing has been a partner in the cleanup, so they spend a lot of money on it. So there is a big plan that's in place, and it's unfolding. But that's y'all get that.
Come on. So are you guys noticing too this acronym STU? Like how many, what did you just use? NPDES, right? National Pollution Discharge something. That's part of how this whole game works, I think. I don't want to be so cynical as to call it a game. A lot of these things are just an alphabet version. So 8 different things under EPA cleanup process. You got your RCRA, your CERCLA, and your TSCA. That means a lot to you guys, right? Very useful terms. Same thing with all those agreed orders with the Department of Ecology. I think 10 or 12 of them are under what's called a VCP, so Voluntary Cleanup Program. The other ones are probably hazardous waste and transport permitting. RCRA is disposal of metals usually, disposal of materials. CERCLA is the name for Superfund. That's the funding law that Superfund comes from. And TSCA is a Toxic Substances Control Act. I can't remember where that one comes from. But yeah, again, right? Yeah. RCRA is especially landfills. That's how I can always remember that one. Yeah, solid waste. Thanks.
Cool.
Okay. So, early action areas, right? So there's this lower Duwamish waterway group of 4 of these people, organizations that realized very early in this process, oh yeah, probably a lot of that is going to be us. And in our case, it's King County, Port of Seattle, City of Seattle, specifically usually SPU, Seattle Public Utilities, and Boeing. Can't believe I forgot Boeing. So these guys have identified already, even as this big EPA process starts, right? They identified spots they could start getting stuff done ahead of time. So they call them early action areas. So for example, Norfolk Street, down near where I live. Norfolk is one of those CSO sites, I believe, once upon a time, but it was a spot where they were discharging to the river, King County, and they ended up with a lot of junk in the sediment, right, from this long-term CSO. Slip 4, Terminal 117, Boeing Plant 2, same kind of stuff. Usually it's PCBs. I'll get back to that in a second. Have you raised your hand? Okay. Good. So the 4 bigs, right? So I can't remember which one I used as a joke. Bis 2,3-ethyl phthalate is in the river, but it's not nearly to the degree that these guys are. So the 4 big ones that they're especially worried about are PCBs, right? Used to get used a lot in coolants, transformers. Very persistent, lasts for a really long time. Which should make sense then, right? That it's the thing they're worried about because it's the stuff that's lasting in the sediments, right? It's locked itself onto something. Arsenic, some metal. Arsenic occurs naturally around here too. Shows up in a lot of glacial sediments. So if your aquifer pulls from a lot of glacial stuff, sometimes you'll test high for arsenic. But then also there was all that metal recycling and metal manufacturing. Jorgensen Forge, I'm sure, did a lot of that arsenic. And yeah, thank you very much. The big smelter down near Tacoma, right, that sprayed air deposition all over the Northwest. How long was it going? So a century. century worth of air deposition metals pollution. Thanks, guys. PAHs and dioxins, furans, both of these are organic compounds that usually are a result of or made worse by partial combustion or full combustion, right? So it's like forges burning stuff and then some plastic gets in with it too. I mean, obviously not plastic in the 20s, but you see what I'm saying? It's burning stuff and burning it in a way where you're not containing everything that you're making, right? All your extra bits. Over and over again, you're going to see cancer, right? Teratogenic. Anybody know what that means? Birth defects, yeah, birth defects. Neurotoxicity. Endocrine disruptor. That's a pretty cool one. Anybody know what that is?
Synthetic hormones.
Synthetic hormones, yeah. I mean, not designed as hormones, but have the same effect in your body ultimately. Arsenic gives you a couple different specific cancers. Okay. So, yes. Basically that table was showing you a range of what they see for those 4 bigs, which goes from really small, probably maybe not going to be a problem, to ridiculously gigantic on some of the PCB reads. So they try to do spatial weighting, is what they call it, but say, oh, we've seen it over here and over here, so we can guess that there's probably this much between them, right? So this graphic is a little funky, but the top one is the closest to Elliott Bay. That makes sense. Back towards Tukwila on the bottom one. And basically all I want you to see here, this is for PCBs specifically, and are they meeting or not meeting various standards, more alphabet soup stuff. Yellow, bad, red, really bad. Right? It's a short version. Where's the good? Great question, Julie. So gray, they don't, see they use alphabet soup instead of saying things like tolerable, but the gray, I think just doesn't meet one of the 2 standards they're looking at that spot. Or it doesn't exceed something, right? So it could be bad, could be a little bad, but theoretically it's better. And this is all, again, sediment, right? That's important to know. This is the bottom of the river, not the water column, okay? Okay. So a lot of cleanup options. Most of them involve scooping stuff up, maybe putting more stuff back. The difference between enhanced natural recovery and monitored natural recovery is the sort of joys that await you when you read these kind of papers, but basically monitored is we'll go back and look at it, where enhanced is we'll dump clean sand on top and assume it will work, that it won't be able to bioturbate. It'll bioturbate its way into the contaminated sediments.
Enhanced natural recovery is actually to activate carbon as something to sequester the pollution in there. And it acts like a water at home. And to the extent that you put that activated carbon would have it sequestering a contaminant, you put it into a plant, and the plant will use it as it uses all kinds of grit, and take it out, and none of the contaminants will be in the plant. So it really does a good job of sequestering those things. But that's the enhanced natural recovery we're talking about. In other words, you knit sand and activated carbon together, and hopefully it will.
They count on worms too, right? They count on bioturbation to carry stuff up and down inside that sediment column. So they have a bazillion, I think it's maybe 19 different versions of how we're going to clean up the river in this plan. That's what all these little pie charts are, is so much dredging, so much enhanced natural recovery at one point, so much of this, so much of that. Okay. Really, I think what they care about is this chart, which is the how long it would take and how many billions of dollars for each of those different ones. Next one. This is one of their preferred alternatives. One of the things I wanted wanted to show, since you guys were already asking about what does gray mean, I can read it over Sam's shoulder. So green here, green is we feel like we definitely need to do this spot. We need to clean up this spot. Dark blue is, in some of the alternatives, we'll also clean up over here. We'll also do one of these options to this area. And then light blue, I wish I could read it, but it literally says something like, no action. Like, we won't do anything here. But then they color everything, so it seems like they're doing something everywhere, right? It's pretty smart. Okay. Yeah?
How often do they update that? Because you have the river moving constantly bringing in new sediment.
He asked how often they update it. Because there's constantly moving in new sediment. The first half of this paper is scour and sedimentation studies, where they're saying we're not seeing stuff build up in these parts of the river, we are seeing stuff build up over here. Does that make sense? So that's part of how they choose where they can do it or not even. So here's a CSO really quickly, just jump through this. Combined sewer overflow, right? When it rains, your toilet water and your water on your street can overload the same pipes. Eventually it can overload the system and they have to discharge it. So they used to do these uncontrolled discharges, which, big surprise, got a lot of sewage and petroleum, right? Whatever else is in the street gutters.
Okay. The other issue down here with the mice overflow is that industries are also depositing into the sewer system. They have permits to do it. And when the system overflows, not just sewage, it is also industrial waste that is going into out of combined sewer overflows. So that's one of the problems that we have down here that you might not have in other places like Washington or Magnolia.
And that is the way I'm thinking. It's the stuff going into Lake Washington. Yeah, thanks, James. And they probably have NPDES permits, right, to discharge it. Next. So there's a lot of hand-wringing and trouble on the horizon about these sewer overflows. King County and the city of Seattle are working with the EPA on a thing called a consent decree. Because, right, you can see King County has 38 CSOs, city of Seattle has 87. In 2012, they had 355 overflow events, 154 million gallons, I think a billion total when they include King County. Some of the stricture, like the stuff that's coming out of EPA is really, really strict. To the point where on a lot of them they aren't supposed to have more than one overflow a year from those spots. So 355 from 87 in 1 year is a lot more than one per. So King County and the city are working with the EPA to figure out what they have to do to stop them, or some other stuff they could do to try to reduce how much is going to the sewers in the first place. So you will hear more and more about this, I guarantee you, between now and 2015. Okay? Climate change, just really briefly, too. Really tiny, but trust me that a lot of South Park would be underwater without levees with a small amount of climate change eventually, especially if we keep having big winter storms on a king tide day, right? When it's a worst case scenario, it's not going to be that hard to get water in there in the very near future. So all of that dark area is spots that if it was a storm and the water level was, I think, 50 inches higher, significantly higher than this one. But places we can expect flooding, in short. Okay? So then, really briefly, my last thing to give you all nightmares is this guy. So Seattle's worst day, it's coming up. Okay? So what's crazy about Seattle and earthquakes is that you've got three ways to win. You've basically got three giant seismogenic earthquake-making places around us that we have seen earthquakes from and expect earthquakes from. Right? So we talked about the mega thrust. That's that one way out on the coast, cold subduction zone. The one in the bottom right, as that plate goes down, it gets brittle, kind of starts falling apart as the water gets squeezed out of it, and you get earthquakes inside of the plate at a pretty significant depth. So 2001, right? Nisqually earthquake, you guys probably remember. Pretty big, but 30, 40 miles down, I think 35 miles down. So not as energetic as if it was right next door. Which, next slide. So here is the front of the delta, right? In this kind of nice diagrammatic picture. You got like Beacon Hill and West Seattle on the sides there, those two hills. You can see where the delta has been building itself out over the years. Do you see that big black line where there's like a lightning bolt near the bottom? Part of the delta is getting shoved up on top of another part of the delta. Okay. That's thanks to your friend and mine in the Seattle fault zone. So there's this giant band of seismically ready stuff. It's a thrust fault, is the short version. So this whole Puget Sound is getting shoved on a north-south axis, getting compressed. And around here, that's making stuff south of this fault zone get shoved up on top of the stuff in front of it. Okay? Right, basically from the end of Bainbridge Island over to Lake Sammamish. It's a really wide zone. Okay. So when it goes, it's going to go big, and it's going to go in our backyard, right? Not as giant as that megathrust. Megathrust is like an 8 or a 9 Richter. This one will be maybe a 7, 7.5. Right underneath us, right? Right next to us, not 35 miles underground. So the state DNR has this really cool website where you can click around in seismic scenarios and see, like, oh, what would get destroyed? So bottom left is Seattle fault. Okay. So here's a map from their seismic scenario. Everything that's red colored here is extreme risk of liquefaction. So you should assume the ground will fail at those points. Everything that's a red dot or like a kind of red squiggly is a broken port facility, oil transfer facility, bridge, hospital, school. This is the kind of stuff that these catalogs track out. The short version is everybody is in trouble, right? Everything gets destroyed. There's no way that the inner part of the valley won't be significantly affected. Go to the next one. Here's the end of the delta. Hang on a second. So I want to rush them almost in. Bathymetry, right, off of downtown Seattle, delta front coming down where the river enters the bay. Next one. This is taking pictures, geophysical pictures, through the front of that delta to look at how solid the materials are in the front. This is a paper from 2013 from the USGS. Red is bad. So those are 4 different sizes of earthquake. The bottom right one is a moderate earthquake you could probably expect even within the next 50 to 100 years, I would say. All that red means the delta falls apart really easily. Next one. So, and even worse, specifically the delta surfboards its way out into Elliott Bay. So again, this is looking at a cross-section of the bay. Everything that's red is going to fail in a way where it just turns to like liquid, right? Immediately falls apart. Everything that's on top of it is pretty cohesive. But with these seismologists who are much smarter and better at this than I am, that long paragraph on the left is a long sciencey way of saying the bottom will fail and it will ride it out into the bay and probably make a giant tsunami as well. In addition to destroying Harbor Island, right? That's Harbor Island falling apart pretty much is what you're looking at right there. Okay.
So have a great day.
So it's been a distinct pleasure, right, getting to talk to you guys. It's almost exactly 3 o'clock, but I'd be happy to answer questions people have. Thank you very much. I skipped Justin earlier, so what did you want to say?
I just noticed there was no risk liquefaction just to the west of Seward Park, probably because it's sitting on that deep rock formation you talked about in the beginning.
That is an excellent note. So it didn't even color it yellow or green, right? Where the rock is, it says, oh, you're fine. Pretty much. Oh, yeah.
I just want to make a comment. I really commend you for the great graphics you had because it really tells a story. I'm all about more pictures, less words. But to validate the one, I really like the one right after it was Lake, the Montana Glacier, and then you had the inland sea before it filled in like with the Osceola waterfall. And working for Duwamish for all the years, we drilled a well south of I-5 along the Duwamish, thinking that we were going to get irrigation from the golf course. We drilled down and we hit a prism of salt water, brine, and we had to cap the well. And that kind of validates your map. I just like the way everything connects. Thank you.
Water. Yeah.
Well, see, under climate change model, it only takes 22 feet of water through here to reach the Army Corps of Engineers at Renton, and the water will be flowing into Lake Washington, which is
How many feet did you say?
122 feet. So if the polar ice melting,
Yeah.
this water will probably be up to there, going valley, instead of going this way.
Unless West Antarctica does that same surfboarding thing. I hope not to see 20 feet of sea level rise in my lifetime. I'd be very surprised. But you are right that it's, right, the 7th generation view. Someone's going to have to deal with that eventually.
Well, we're past the tipping point, so now the moment, the melting can become extremely accelerated, and this will all be underwater. If that happens.
Especially if they find a canyon in the middle of Greenland. Yeah. Same thing. Thank you. Yeah, Mike.
I read in CI online the last few years about big development of money in Tacoma that was to be related to industrial park in the state. And I read that they've already started doing mitigation projects. They know it's going to affect rivers, and I'm wondering if you know how it's going to affect the Longhouse.
James is pointing at someone who knows a lot about it.
So I work for Duwamish, but I'm on the planetary stuff. As of yet, we've never gotten any proposal on that. So if you can tell me where.
Yeah. We do a leverage for Kigali to Kola, and Senator Murray, supporter. It's definitely in public, like in the sky.
So.
Spruce plant.
Yeah, so there
And
is.
mitigation project close to Kent, or Kent to Kola.
Yeah, and that's not new. That's been going on for 7 years, and the developer is getting in place. And yes, he has to do a lot of mitigation. He is a major developer. It's kind of the South Center Parkway Craig Road area. So if you go south of 180th all the way to Kent, 192nd, that's that entire area. He's reconstructing roads. He's doing major excavation, and yeah, there's a huge developer agreement that he had to provide to the state.
Will that affect the Duwamish, or?
Well, it affects the green, but what he's done is he has had to create wetlands and areas where he does his own on-site treatment. So he's created 3 ponds to filter and do work in that area. So yeah, it's pretty major, but he has to meet the current regulations.
So it's kind of industrial location to wetlands?
Yeah, he's got mixed use, although we all know him as a warehouseman. But he does have various things that he has planned, but it's really a long-term thing, so I don't know how that will.
I think your point about Senator Murray supporting his work and advocating for us and important one. He also taught some online activity updates that went on, and Murray was supportive there as well. So it's something to do. He's cognizant of that, and he's right.
The guy we're talking about is the guy that built this house. He sold it. And now he's expanding into another industrial park, which is usually warehouse space.
Well, the other fan that I saw in the area is the big dam that has the Wheel area that is years in the first place.
So obviously, right, this is not a story that's over. So I really appreciate that. I haven't heard of either one of those, so I'm happy to look into what that means. But I don't want to keep you guys here all day, and I can see Linda dead. So thank you very much. If you want to, you can get me later. And I've got a sheet in the back where if you want me to send you the PowerPoint, right, you could write your email down. I'll send it to you.
To answer your question at the beginning, diamides are the plastic softeners that we use, and they're ubiquitous throughout the area, and it's also an endocrine disruptor as well. And it's in every stormwater pipe anywhere in the city. You find it everywhere. And so when you have a problem like that, hopefully we can find another way to soften plastics that don't do that type of thing. So there's two ways to deal with contaminants in our watershed. One is to either stop the flow of them, or the second is to actually chemically engineer or re-engineer things so that it doesn't pollute in the same way as it was before. It's a plastic softener. You find it in tires, you find it in every plastics that are made.
So like case in point, how we could keep microbeads out right now is a thing that New York and other people are working on. But anyway, we could do this all day.
Okay, so I know it's almost impossible to sit on these benches for 2 hours, so we're not going to keep getting longer. But I can see there's interest. So I want to thank you for holding in there, and we'll do some more programming. So I hope that related programming, and James actually is a long time steward of the Duwamish River, and he's the current coordinator for the Duwamish River Cleanup Coalition. And he is a member of the Duwamish tribe and was the Duwamish River steward also for a long time as a council member. And so those maps that you got, those are from the Duwamish River Cleanup Coalition. And James, you know, how many of you have ever taken a boat tour on the Duwamish River? Oh, quite a few of you. How many would you like to do it again or do it for the first time? Okay, make sure you sign in, and I'm going to arrange with James so we can do a boat tour. It might cost you $10 or something because they have to rent a boat to do it. So we'll have to cover the cost, but it'll be really nice. And make sure you get our calendar of events. We do cultural events and other things. You can always check our website. We deeply thank you for coming, and Devin has done such a wonderful job. And the Parks Department said they might help us with some programming with the Volunteer Naturalist Program. I said, you know, geology is the biggest interest. And they went, really? They went, we got somebody. So I would like to thank the Parks Department too, and wonderful work. Thank you so much. And please come again. Thank you.
Not your email, so I'll shoot you an email so we have that connection.
Let me write it on the stand. Because I don't have a pen. Do you have a pen?
Oh, I got it off of your
Off the sheet, yeah.
let you know that I'll be in touch with something.
Sounds good. See you in mid-April.
Awesome.
I get that.
Okay.
Nice to meet you, bro.
Yeah, you too. Thank you.
Tim Group. So, just wanted to share this piece of geology. If it wasn't for a drumlin, it wouldn't be a Mormon church.